Hi everyone, welcome to Data Scientist series. Today we are doing the logistic regression. So in the last session we have done the linear regression. Now what is a logistic regression? So logistic regression is basically used for predict the outcome of a given set of independent variables. So logistic regression is basically you can say we have the independent variable and dependent variables. So we have the independent variable. Let's suppose they are showing the predicted lines between the 0 and 1s. So in the logistic regression, we don't have the continuous variable. Here we have the some binary outcomes like 0 or 1, yes or no. So like this we have in the logistic regression. So logistic regression, in this we will use a sigmoid function. So what is a sigmoid function? The sigmoid function is the probability of logistic regression represented by sigmoid function or logistic function over as a S curve. So this is a formula for the logistic regression. So as divided by t and 1 divided by 1 plus e, and the power is minus t. So t is represent the data values and the numbers of our studies, and st is represent the probability of passing the exam. So let's suppose this example is related to the students is doing the studies. Let's suppose the student doing the 1 hour study, then the probability will be very less, and 2 hour study is very less. But if they started the 3 hours and the 4, 5, 6 hours, you can see here the sigmoid, the line is going like this. So sigmoid line is going the up and down. You can see here if my hours is also increased, my the sigmoid value is also no going up. So here the outcome will be 1 and 0 only. So here let's suppose he's doing the 6 hour study. That means the probability of the passing the exam is very high. So here we have the example. The sigmoid function is a S-shaped curve, and the y variable here, this is x and this is a y. It's a 0 and 1. So this is sigmoid function we are using here, and that is a threshold. So here we are using the perceptron, the value. What is a perceptron? So that will be doing in the more details in the coming session. So perceptron is is an algorithm for the supervised learning for single layer binary linear classification. The perceptron is classified as a linear algorithm that can be applied on binary classification. So it learns our decision boundaries and that separates two classes using the line called the hyperplane. So this is my hyperplane. My hyperplane is going like this. So if here you can see here that the threshold value is 0.50, and when my value is greater than 0.50, then it's going to indicate that the passing, and it's greater than the 1, so sorry, greater than the 0.60. That means the probability of passing is going high. So if my value is 0.60 and the above, then we are taking as a 1. If my value is less than 0.50, then we can taking as a 0. So here this is the yes for the if the value is greater than 0.50, and if it is less than 0.50, that indicates that will be no. So if value is less than 0.50 is no, and if value is greater than then it's showing the yes. So here you can see here the formula is 0.50 and set the value 1, else set a value y equal to 0. The probability of distribution of the output y is restricted to 1 to 0. This is called the sigmoid probability. Okay, so there is no closed form solutions for finding the optimal weight in the logistic regression. Uh, let's see the example for the linear regression. So I'm taking the example for the tumor. So let's suppose we have some data. So I write it data first, and now we will see how we can calculate this. So for this, first of all, I'm importing the numpy because I created some array here. So this is x, where x value is here for the X value is showing the tumor centimeter size, and the Y is showing the if tumor is here or not. If 3.78, so it's showing the 0, or the 2.4 is showing the 0. If my tumor is going high, so it's showing the value 1. So we reshape it, and now we given the Y yes or no. And if you have the yes or no in your Y variable, so convert it into 0 and 1s, then you can do the probability. So for this, I'm using here, I'm importing the one more library that from sklearn. From sklearn, that is the linear model. Okay, so that I imported for the logistic regression. So now I'm creating the one variable as a log as a logistic regression, and now I'm using the linear model. So in the linear model we have the logistic regression. So I'm writing here logistic. Now you can see here this is a logistic regression. So I use it logistic regression and I run it. Okay, so simply I'm not distributing values here in the X train or Y train. I'm using simply as a logistic regression here. So logistic regression, now I'm fitting the variable only, fit X and Y. So we are fitting that X and Y here. Sorry, my X is capital here and here is a smaller. Okay, so I fitted my logistic regression here. Now I will predict the future value. So how we can predict the future value? We can simply write the predict variable. So I'm writing here predict and equal to my log, that logistic regression we have taken. Now we are using the predict feature. This is a predict function. We are using the predict function here. Now in the predict function, I'm simply writing using the numpy here for creating the using the array. So numpy dot array, then I'm passing one tumor size. Let's suppose the tumor size is a 5. Okay, and then I'm reshaping here, reshape array. We need to close it, then reshape it as -1 comma 1, then close it. Now you can see I predicted. Now predicted variable is running fine. Now I'm predicting the what is the probability of this. So probability of if the tumor size is 5, its probability is 1. That means tumor is there. But if I'm changing the probability of this as a 1, sorry, I'm changing the tumor size as a 1, and then I'm running the predicted variable. Now it's showing the 0. If my tumor is going high, if my tumor is 2.3, 2.3, then let's see the probability of it showing the 0. But if it is going more than 4, now it will be show the predictability as a 1. So this is how we are doing the prediction in the logistic regression. It's showing always the result as a 0 and the 1s, yes and no. Now you can convert it easily with the yes. If 1 is here, that means the probability of the tumor is a 1, and if it's a 0, that means a probability is not there, that no tumor is there. So this is how the this logistic regression will be work. Thank you guys.